No, it's not.
That's epic.
It's like, oh.
Well, actually, that'd be a little annoying. Well, I do everything late.
Sometimes, like, it's like, when I do started, like, my mom went
Oh, and so I just got the
and so I don't know how to do it.
Yeah, I can't do it, Mom.
So, like, I'm over, like, looking at our lessons for the
You're right.
All right, you're gonna
I'm just saying class.
Yeah, I'm like,
Okay, focus up here, everybody. So, Unit 8 is focused on acids and bases. Now, back in Unit 4, we did a brief intro to acids and bases, and we talked about conjugate pairs. Now, your head, if that sounds like, oh yeah, that sounds familiar. Okay, we're going to dig into your brains for your smiley faces. So with these two equations up here, you're welcome to pull your notes out and use your neighbor.
I would never use somebody. Yeah. Are you suggesting I use another person for my own personal gain? Awesome. Taylor. Well, Taylor's not here. I always use
Okay,
Taylor.
with these two equations, I want you to label the acid, the base, and the conjugate acid and the conjugate base. Okay, you got 2 minutes. Ready?
Okay,
Go.
the acid is the H plus.
I need my notes. I'll
Notes were green, by the way, if you want to look back that far.
Wait, what's the question? I
Wait,
can't acid.
so the acid
Label the
takes
acid and the base and the conjugate
Okay.
base.
No, the base takes a
Oh,
acid gas.
okay. So,
That's a word. You're killing me small.
wait, so H2O is the base? Okay. So, con base, acid,
I don't want to write out conjugate.
H3,
Just do
H,
back up. Wait, no.
con,
what?
So this one is giving away its hydrogen.
and then that would be, which one gives
Oh,
it?
oh, it's both.
When I hear it's conjugate acid, because that one's gonna give it back. Conjugate base, that one.
Yeah. So,
So label the acid, the base, and the conjugate acid and the conjugate base.
I got
this
it.
is the base.
Oh,
Oh, wait.
Got it?
Wait.
4 smiley faces.
It's a profile, not an
Okay.
You dare make fun of my coin and knuckle rolling and then you don't even do a number?
These two are even related.
What do you mean?
So the acid takes the hydrogen.
So this is made up of molecules.
Plastic ball.
Or this is base.
Alright, you got 16 seconds.
Yeah, what do you think I
So it's like if
made
you
it?
flip that, which one would be?
I appreciate your.
Oh,
your
okay. So it's like switch.
But sadly, no, I don't know how to make up the bigger Jim.
Alright, pencils down.
I know what it is. Can I write it on the board? I'm that confident right
You
now.
want to do it? Sure.
I kind of want to. I'm so gonna get it wrong now, but I really want to try. All right. Do I want a pumpkin?
No, those are stale.
No, thank you.
Those are stale.
All right. So, I think this is an acid. Cool. Now I make this a base.
So you have one smiley face if you labeled that side of the reaction correctly.
Because of science, this becomes the conjugate base. And this becomes the conjugate acid.
There's a second smiley face if you labeled the conjugates correctly.
Oh, you did it.
Okay, you good before you put the answer up there?
You were right.
Don't write fast, don't write fast.
Oh no.
I don't think that's cheating if you don't
Oh
know the
no,
answer.
hey, it'd be a while to walk over.
A very long line.
I'll just write the first line in each.
Okay, I'm ready.
Wait.
Yes, this is what my notes said anyways. Acid.
I mixed them up.
Did I do this one wrong then? Or am I good?
You're good so far, keep going.
Con. Acid. Wow.
There you go.
On. Base. I'm sorry I'm left-handed. This is probably annoying.
Well,
Yes.
questions for Professor Gavin?
Yes, I'm a professor now.
Yes.
Wait, so how much slide is
So 4 slide bases, so it's,
Gavin, you look like a professor that's ready for
1, 2,
disaster.
3.
Always ready.
Okay, so just a reminder as we're jumping to acids and bases that I heard a lot of you saying this or questioning this. Okay, so acids donate or give their age.
Oil rig, I forgot.
Now that's redox, bro.
That's a redo.
That's all.
But it is about, you're right in that it is about losing and gaining. Now the conjugates are, meaning if you look at the reaction in reverse, this now can behave as a base, and this can now behave as an acid. Okay? Now, as we're looking at acids and bases, everybody, something that's really interesting and kind of foundational to this classification. Keep in mind, the word acid and base are just names that scientists said, hey, we're going to classify these things and by acid because they share this property. It actually comes down to the interesting fact about water. You notice in this reaction, in this first one, water acts as a base. In the second one, water acts as an acid.
Wait, there's
Wait.
the notes about it. I think it's both.
Yeah, so it's known as amphoprotic or amphoteric, they mean the same thing. Where something that can behave as an acid or a base depending on what it's with. Now here's the really kind of strange thing about it, because you have water, you drink it every day, should. Okay, water can react with itself. So,
Wait, what? Water.
You could have a reaction if it's
So if you have a cup of water, you drink it, and then you drink it.
so yeah, what Evan's saying. So literally, it's happening right before your very eyes in this water bottle. Okay, one water can collide with another water and make hydroxide. That's the name of this substance, and hydronium.
Wait, why?
That sounds like
Okay, because one of the waters, as they collide, gives up its proton or its hydrogen to the other, and so it's acting like an acid and a base at the same time.
I don't know this bit. I don't know.
Okay? So when I take a drink of water, what am I drinking?
You have no idea.
Hydroxide and hydronium.
Oh.
And
H2O.
Why do you say and, right? And that.
back and forth.
Good. It's an equilibrium. Okay, now first off, some people all of a sudden their brain goes crazy and they're like, wait, do I even drink H2O? Yes. And to be honest, the KW value, put this in the box below that says KW equals. So KW is the equilibrium constant for water. That's why they label it with a W.
Right.
How do I write equilibrium constant?
Product.
It's
Good. So product over reactants. We have OH minus, H3O plus. Now what do we exclude from equilibrium constants?
Liquid, solid,
Pure liquid.
Pure solids and pure liquids, so
Oh,
we
so it's
don't
just the-
put the H2O in it. So KW just equals these. And at room temperature, scientists have found that it always equals 1 times 10 to the negative 14. Evan,
so if it's at room temperature, can room temperature vary though?
there's a standard room temperature, it's 25 degrees Celsius.
Okay.
But yeah, if we're not at 20, I guess I should say that. So if this is only at 25 degrees Celsius.
So if I heat my room to 26 degrees Celsius,
Hmm.
that's room temperature because it's the temperature of my
Of
room.
his room.
Okay.
Yeah. Okay, so this will vary, but if you're at 25 degrees, it's always this number. Now, what does this number tell me about this equilibrium, Matt?
It's reactant favored.
very, very heavily, right? Like this is teeny tiny number. So how much of this are you drinking? Not much at all, right? Most of the water we drink is H2O, but to some extent, it does turn in to these two things. Yeah.
Wait, so is that number like essentially just telling us that one out of that number would be those things, or no? That just means.
Not quite. It's not
Okay.
like quite a proportion like that.
Okay.
I don't know how to put it into a proportion, but yeah, but the smaller that K value is, right, the less products are being made. Now, the way that scientists have classified, oh, here's some blanks to fill in. Okay, so we call this process the auto-ionization. Auto-ionization meaning it's reacting with itself. Okay, and it, once again, because it's at equilibrium, it's happening very rapidly in both directions. Right, because that's how equilibriums work. Oh, I guess here's a proportion that the book gave us. But what they find is that only 2 out of what's 10 to the 9 billion.
Very much number.
Okay, oh, that's your good. So every 2 out of 10 billion water molecules actually breaks apart. The rest are H2O. Okay? But what's interesting is the H plus, or the hydronium and the hydroxide, are the way in which we classify acids and bases. Primarily by the hydronium. Now make a little note, because it's been a while with. So H plus is the same thing as saying this. Okay, this is the simple way of writing it. This is the true way of writing it. Because anytime you have one of these in water, it's going to link to the water in Venus. But scientifically speaking, all chemists understand this as that and that as that. So however you want to write it, just I just know in my writing, because that's all you'll see on the board, I typically just do H plus, so it's easier. But it is the same thing. This is also known as the ion product constant for water, is its name. It is on your formula sheet, FYI. Almost every formula we talk about today, which we have a lot, are all on your formula sheet. So you don't have to memorize the formulas, we just need to know how to use them. So, once again, it's all about that relationship of H plus to OH minus. Okay, when they are equal to each other, a solution is neutral. So water has been classified the neutral point of what is known as the pH scale. Raise your hand if you're familiar somewhat, or heard of at least, the pH scale. Everyone's heard of it? Awesome. Anyone can describe kind of like what the pH scale is? Kimberly?
So I'm not going to do super well, I apologize.
You're good.
But it measures how much H plus or OH minus is in a solution. Basically, the lower the number, the more acidic, and then the higher the number, the more basic. And then pure water is about a 7. It goes from like
Good.
1 to 14.
So 7 is considered the very middle of our pH scale.
I feel like you explained that very well.
That's what that was looking at.
Don't sell yourself short.
Have a smiley face for that explanation, by the way. So, pH of 7 is perfectly neutral. Now, when I say 7, to be perfectly neutral, we're talking about 7.00000000. Right? Anything that slightly goes up or down is still close to neutral, but it doesn't make it perfectly neutral. Now, when the H plus is greater than the OH minus, that's what classifies something as an acid. On the pH scale, acids are less than 7. So anything less than 7 is an acid. Anything greater than 7 is classified as a base. And the farther away you get on the scale, the stronger that acid is, or the higher the concentration of the H plus. Now what's important to recognize is even in all acids, they always have both. It's just a matter of which one is more than the other. Okay? So let's look at the equation of how we calculate pH. So pH is calculated through a logarithmic function. It's once again, it's just a scale they set up. It has no units. It's just a way of showing a number that can be hard to look at in an easier way. Primarily, it takes things out of concentration and into just a number. So to find pH, and this is on your formula sheet, pH equals the negative log of the H plus concentration.
Does that go in the box?
Yeah,
Okay.
put that in your box, sorry. It's that slide, it's off my board a little bit. Now, in case you have bad feelings towards the log, possibly from your past experience, there's really not much you have to do with it here besides push it on your calculator. And then slightly understand that it's a base 10 function. So what's important to recognize with it being logs is that the difference between the pH of a 6 and the pH of a 7 is 10 times the difference because it's a base 10 function. So just kind of be aware of that even the difference between like 7.5 and a 7.6 pH can be deadly to us as humans. Yeah?
For example, like battery acid is a 1, a lemon is a 2. So like the difference is really big.
Yeah, but like you definitely should not be eating battery
Yeah.
acid, but we can eat lemons and you might feel the corrosion a little bit, but yeah, great example, thanks Kimberly. Okay, pull out your calculator and your habits today, and let's practice typing.
Battery acid is a one.
I love the pH. Only thing I said.
My calculator's dead. Yeah, it's out of math today. It was really just
Yeah, that's why I eat lemons on anything. I love the taste of corrosion. Yes.
No, but that's like literally why, like if you drink too much, like
battery acid.
any battery acid. But like one time when I was younger, and not as wise I guess, I was starting to get sick. And I didn't want to get sick, so I was like, I'm going to drink lots of orange juice.
Uh-oh.
So I drank lots of orange juice to get my vitamin C.
Smart.
And it was smart minus the fact that my mouth got full of canker sores because it's acidic and
Okay.
Canker sores are so annoying.
That's an epic
Sounds like
base.
a
Is bleach a base?
Uh-huh.
Cool, yeah, that would have been the way to go.
Okay, here's just kind of what I said. I don't know if there's a blank that you're supposed to do with it, the times 10, but recognizing that difference. Okay, let's look at a problem here. So this one says, first off, we're just going to focus on finding the concentration. So you can describe acids by their concentration, but the pH goes to develop because it's easier to look at than numbers like 0.01 or 1 times 10 to the negative 8 and things like that. So this one wants us to find the concentration of H plus in a solution where the OH concentration is that. Now keep in mind, these things are related through that KW equation. So KW we said equals OH times H plus, and that's on your formula sheet. And it always equals, because we're assuming we're at 25 degrees Celsius, 1 times 10 to the negative 14. Yeah, Evan.
Does K always mean constant?
So capital K is always for equilibrium constant. It just depends on like what equilibrium you're looking at.
Wait, yeah, little K, wait, didn't we learn little K?
Yeah, little k is the rate constant. Okay, so we're gonna plug in the OH. If you want to draw an arrow from that number so you know where it came from. So I'm just gonna plug in 0.1 here. We're trying to find H plus. We're just gonna divide it through. So we can find that H plus equals 1 times 10 to the negative 12. Now, to identify if this is an acid or a base, we're looking at the comparison of H plus to OH minus. So this is how much OH I have, this is how much H plus. Let's do thumbs up for acid, thumbs down for base.
K.
Oh,
acid and
Is this an acid or is this a base?
Basically, it's big.
This is H plus, this is OH.
Base.
Think about it.
Acid is base.
Okay.
Wait, which one are we trying to find? The like,
So, is this solution an acid or a base?
That was
Water.
really
It's
small.
gotta be a base. How are you supposed to tell? Because we wrote it down, the concentration, if it has more H plus, it's acidic.
You're
If it has
giving me
more
a thumbs
OH.
down. A smiley.
Yeah.
So this is a perfect example of why they made the pH scale
Hey, wait, what was thumbs down?
base.
Yes.
Because looking at these numbers, everybody,
Oh, I thought
So then give
if you
yourself
got
a
base,
score.
you got it right. So, but looking at these numbers can be a little bit tricky, especially because of like the negative exponent. So this number is a lot smaller than this number. So since you have more OH, that makes it a base. Right? If you had more of this, it would make it an acid. Okay? Now, once again, it's important to recognize that both are always there in every acid-base thing because it all comes from water. It's just a matter of how much of each you have.
That's so weird that it all comes from water.
Yeah.
That's so weird.
Weird how that's like the kind of where
And
it
it
was
happens
developed
like
from.
at such a small scale. Like, weird.
Okay, now let's take this number and find the pH value of our substance. So if I take 1 times 10 to the negative 12, type in negative log of that number in my calculator, I'll get 12.
Whoa.
Wait.
What?
So you do negative,
So,
log,
Because that was the formula.
and then
pH,
you plug
right?
in what we got for H plus, which is
Yo.
1 to times
You
10
know,
to the
this is how I always feel. At the start of a new unit, I feel like I get it, and then towards the end of the unit, I'm like,
Yeah, once we start the homework, I'm like, yeah.
I'm like, no, where did I go
Those
wrong?
AP,
Oh, the quizzes.
oh my gosh, I get a mind blink when I get home.
yeah, I'm like, I don't know what you're asking me, sorry.
Okay, let's talk really quick about how to estimate a log, because there will be there's a good chance there'll be multiple choice questions with pH and you don't have a calculator. Now, for those that have never done this before, it's maybe simpler than you realize because it's just a base 10 function, and concentrations are always times 10 to the something. So to estimate the pH value without a calculator, you just look at the power of the 10. If it's 1 times 10 to the something, that is literally the answer.
Fascinating.
So it'd be 5.6 times 6.
So now this one, it's not going to be exactly 6 because this isn't 1.
So it's gonna be like 30 or something.
No. But we can estimate that the pH is going to be between 5 to 6.
So the bigger the number out front, the smaller it makes the value?
It's just always a range. So whatever this is, it's always a range with that being the highest.
Okay.
So if this was 7, then it would range from 6 to 7.
Oh, okay.
Does that make sense?
No matter like,
No matter what that is.
It's like a
Yeah.
10.
Even if it's a
It
million.
wouldn't ever be because of the way you write scientific notation.
Good point.
So, yeah. So what I'm saying is if there was multiple choice, you just have to get it to here and then you'd be able to pick. They're not going to make you pick between 5.2 and 5.5 on a multiple choice. But let's practice really quick just typing it in to make sure we've got it. So everyone type this in your calculator. Have a smiley face if you get the right answer.
What log function on your phone?
There's a calculator right behind you that someone borrowed last week you could use.
This is mine now, Gabe.
Oh,
Five.
how many do you have?
Negative 6.
Oh, yeah, Josh.
You want to just take it from office? There's just like little buckets out there. Thanks.
5.25.
because we're not going this big, but I was curious to know how it's gonna be the next week. Obviously depending on how much it snows.
That's what I have no clue.
Okay, if you got, everyone ready? Had you type it in? Yes.
And if I have log base 10 button on this, what do I need to get?
I don't know, I hate
You
to
type
type
in,
it in on
you type in a number, so.
You have to like do it backwards, you have to normally type the number and then hit the
Yeah, 5.6
function.
EE.
Apple's so smart, but they need the dumbest guy.
Yeah, especially on the Mac.
It's
It's
like
so dumb.
Casio.
Because whenever I click on it, it only comes up with, like, if you held your phone vertically. I can't even make it
Do
sideways.
anything, I know.
So I have to go to Desmos every time.
Okay, if you got 5.3,
Wait, how do you do
or if you didn't round it, you can have smiley face.
So is the 6 things based off the 5.6?
Yeah, so this is what we base it off
And
of.
then you try and.
Base it off of.
Yeah. Okay, questions on calculating pH so far?
You should.
Okay, let's talk about the reverse. So if I'm given a pH and I want to change it, so this was our equation, but now I have this and I want to know that. Now this equation isn't on your formula sheet, so if you're not familiar with inversing a log in math, then you need to memorize this. Anyone know how to inverse a log?
Oh, to like.
Oh, you have to put the thing up there, like the other thing
Oh,
down
close. That's the inverse for natural log, but it is the same idea. So because it's a base 10, you do 10 to the negative pH will equal pH plus. Once again, all the other formulas I've written are on your formula sheet, but this one is not. So make a little note to yourself. So I just do 10 to the negative 3.76 to find the concentration in my apple juice.
That's it?
Is it apple
Yep.
juice?
Which was 1.7.
Yep. So it's 10, negative 3.7. 1.7 times 10 to the negative 4.
I've never got finger sore.
Really? Well, you probably weren't chugging it.
Should have been drinking more. Okay, what's the unit on this though? This does have a unit.
pH.
Moles per gallon.
Oh.
Yes.
Just
Just say gallon.
It's so sacrilegious. Oh my God.
I'm sorry, I should just leave.
Okay, questions so far?
Yeah, the freaking Imperial is trying to.
We're not going by empirical
Okay.
standards.
Now, I'm just gonna show you a bunch of other equations that you can use. These ones are all on your formula sheet, but it just kind of, there's a lot of different ways to sometimes solve these problems because of all the equations you have. It's just an algebra at that point of rearranging, but we actually also have a scale that is known as the POH scale.
Oh my gosh, now that thing confused me. What's that?
Well, it's not really like universally accepted.
Oh.
Like, well, I guess it's not the one that's ever discussed. So pretty much POH, anytime I'm working with it, I just convert over to pH.
What a waste of time.
It's helpful to get there. You'll see where it kind of helps. But in terms of like actually using it as a scale, so this should go in this top box up there. Okay, so POH, put this in that top box, equals the negative log of the OH. So this is where it kind of is helpful. If you're measuring a base, it's often easier to measure this concentration than it is the H plus because there's more of it.
Okay.
So then you can find what the POH is for the base, and then the connection is that pH plus POH will equal 14.
Yes,
Always?
that makes sense, that makes sense.
Oh, at room temperature? At 25 degrees Celsius?
Wait, does that go like?
But yeah,
the
which one does
box?
that go in the top?
This actually goes in the bottom box. I skipped the middle box on purpose, actually.
Get out of here. Nobody likes you. Stupid little box.
Well, we're gonna come back to that.
Oh.
Sorry about that, robot.
So this is like being a middle child. Parents be like, who cares? And then like, oh wait.
You're the best.
Yeah.
I was a middle child, so.
Same.
Okay.
I'm middle child.
Okay, any thoughts of why it's 14?
Oh, the
Because the
pH
pH
scale.
Ooh, self-roast, those are rare.
Yeah.
So, KW, right, was 10 to the negative 14. And so it's all based on that relationship of with water. So we have a POH, we have pH. This middle box, we actually have something what is known as the PKW.
Why?
Now anyone catching the trend here? What would PKW equal?
14.
Equilibrium constant of water.
Would it be
10 times
POH
something.
minus pH equals
The negative 7?
14 minus?
The logarithm.
1 times 10 to the negative 7.
Stop! Oh, that's right! Okay, so what is pH equal?
10, did you say 10 to the power of 14?
So pH equals the negative log of H, right?
Oh, yeah.
POH equals the negative log of OH. So
Oh,
PKW means
the
the negative log of
4H less than negative.
KW, which is 1 times 10 to the 14, which equals 14.
Oh! Oh! Get out of here! Get out of here!
Wait,
Oh!
so P just negative log?
Yes, Evan. So that's kind of the big thing is recognizing that P is just a letter that is a way of saying take the negative log of this thing.
Why don't we just write
No,
negative log instead?
Wait, so
Because we're
It signifies, I don't know. I don't know how to answer that. But the P is there because of the word power from what I researched.
Okay.
So like pH stands for like the power of hydrogen.
Okay.
Because you're taking like it's a power base 10 unit. But yeah. So
Wait, PKW is just always 14,
yes.
and so negative log of KW is always 14.
Yes. Because what's KW equal?
Room temperature water.
What he said,
1 times 10 to the negative.
what they
14.
said,
Yeah.
that's it.
And these three formulas are all on your formula sheet.
Oh.
So yeah.
Why do, maybe just understand the process, but like why do we include negative log concentration KW then? Because why don't we just say PKW is equal to 14?
I'm just showing you where it came from, like where that 14 number is. But it does always just equal 14. So, but yeah, you really don't ever have to like plug it in. So. Now, let's talk about this last sentence and put a big star by it, in case you don't miss it. We've talked about that equilibrium constants change when temperature changes. That's why we've been emphasizing the 25 degrees Celsius. If you're not at 25 degrees Celsius, the value of KW is not 1 times 10 to the negative 14, which means PKW at that temperature would not equal 14.
Oh no.
Which means what happens to the pH scale when you get out of room temperature?
Oh my god. It's falling apart.
It kind of does. Or it gets weird. But now here's the big question. Don't say it out loud.
Yeah.
Just think in your head, and then I'm going to have you nod your response. Say yes or no. And everyone has to have a vote. There's no maybes here.
Yeah.
Okay.
What would it maybe be with your head?
Just go like this.
You just go, yeah.
Or they keep changing. Like I look one time and they're doing this, and then I look back and they're like this. Okay. Think in your head, and then nod in response. If KW changes when I increase temperature, does that mean when I boil water I'm making it more acidic? Yes or no?
Oh.
Oh.
Okay, wait, can you repeat it?
Uh-huh. So since KW changes when temperature changes, does that make water more or less acidic when I heat it up or cool it down? Either direction. So yes, it changes it, or no, it doesn't. So we know K changes. Does it change the water in terms of making it more or less acidic? Anyone have their response? Okay, show me your response. Yes or no. I won't judge you. I literally have like short-term memory loss, so I'll forget what you said in a second.
What'd you say?
No, because then water does taste different however.
Maybe if we, wait, so that means if I freeze bleach, it's even better at cleaning stuff. That doesn't make any sense.
Okay,
If I
so
put bleach in the fridge, no, that's
the
dumb.
correct answer is no.
Cool,
Yes.
okay.
Have a smiley face if you chose
I feel
no.
like it should, but like at the same time.
I
Anyone
don't
willing
understand
to justify for us why? Zach?
Is it because it's like shifting it more to the product where the product is both acidic acids and bases, so it's like just keeps it the same, like concentration ratio?
So well put. Have a second smiley face, Zach. So,
He said so many smart words right there that I don't even know.
so the reason why water is why is water classified as neutral?
Because it's
Because-
7.
It's not because
Because
it's
the acid
seven.
makes it
Seven
equal.
we labeled as neutral.
It's just at equilibrium.
These two things are equal. They're the same, not that.
I was gonna say,
Okay, I'll
what is
go.
the point?
So this and this are equal when something is neutral. If KW goes up or down, it doesn't change the fact that these are still equal. So pretty much it's just that the pH scale is very deceiving outside of 25 degrees Celsius.
Wait,
That makes
so
sense.
it does or
No,
doesn't?
what?
So it doesn't make it, will the pH go up or down? Yes. But
But-
is it truly like more acidic? No.
Okay.
Ah.
Does that make sense? So the
yeah.
pH will change, because the pH is just measuring concentration. But in terms of like more, something more acidic means you have more H plus than you do OH minus, right? So, questions on that? Claire, something else to add?
Oh, I was just gonna say, well, if the pH changes, well, the pOH is changing as well, so it balances it out.
Perfect, yeah, it's like that dynamic relationship of both of them, right? So, good. Okay, any other questions on that?
Wait,
I just
so
don't
why would the
understand how it
concentration change with the temperature?
Because it does possibly make more H plus or OH and OH or less as temperature, because, well, I guess I don't know, is the auto-ionization of water endo or
That's
exothermic?
the thing, and so which,
What? That sentence.
I don't know. I'll have to look that up, I'm not sure. Yeah, because depending that, it would make more, but because they're equal to each other, it like balances it.
right,
This is too much.
So if I have more
Okay.
acid,
I'm weak.
I was watching.
or if I have
Now,
more
next thing to make your brain hurt a little bit.
I know.
Bring this already.
Okay, in chemistry or in science, we label or classify, I guess is the better word,
I'm so confused.
as acids and bases as either strong or weak.
Ah. Darwin. I thought we get rid of all the only the strong fulfill our
Well,
nation.
you can make the weak one. So is it-
Why would anybody choose to make something that
Well,
is
it
weak?
will affect your reaction, so if it's a
Weak.
really strong one, it
Weak cowardice.
Now, what is
All jokes.
highly encouraged is that you memorize the 7 strong acids that are classified as strong. Because there's only 7 of them. And then if it's not on that list of 7, you just by default classify it as weak. Now, next time there may or may not be a bonus quiz worth like 20 points.
What?
Whoa, that ain't a bonus quiz.
Wait,
That's a
rewind,
test.
that, yeah.
Wait, we
Well,
need to
join
rewind
our
on
quiz
that one.
category.
Wait, what? What? You said 20 points?
Rewind.
So I'll put it in quizzes out of 0.
Oh, no.
Which doesn't make any sense. How do you divide by 0?
By having these memorized.
Technically, if you limit.
Okay, so these are the 7 strong acids.
No, stop. Stop now, please.
Infinite extra.
Okay, so memorize
Wait, I
those
like
7
that.
formulas as strong.
Okay, wait.
Then, if you read a problem and it's not one of those 7, Then it's just by default weak.
We.
Now, what we mean by classifying something as strong is strong acids have complete ionization.
Facts.
Meaning it's not an equilibrium. Strong acids and strong bases do not make an equilibrium, they break apart all the way.
That's insane.
Okay, so what we get here is all of this actually turns into, because this is donating as hydrogen, we get NO3 minus and our hydronium. Now this first equation up here is the like technical what's really happening equation. The second equation is the simplified one by removing water.
Get out of here.
So you can't also just write it like this. These two things mean one and the same. Okay, so whatever method you prefer to write. So once again, the definition of a strong acid is that it completely ionizes and breaks apart. So if I have a container of hydrochloric acid, which is one of our strong ones, do I actually have any HCl floating around in there?
No, you don't.
No, you really just have H plus and Cl minus floating around. Okay. Same thing for the bases side of things. Oh, I guess our base list is on the next page. Let's do a problem real quick. So let's calculate mathematically the pH of a strong acid. Okay, what do I need to find the pH of something?
The
OH minus and H plus.
Technically just H plus.
That's a good point.
But OH, like, if you had it, could give you that. So I want you to make a little like, I don't know. We're gonna do a little chant here. Okay, ready? Just to get this in your brain.
The concentration.
Yeah, to add to our Lichat dance. Okay, when I say pH, you say H plus. pH.
H plus.
pH.
H plus.
Okay, good. So sometimes students get so tripped up when they read a question and they lose track of what they're trying to get to. Okay, we need to find how much H plus there is to find the pH of a solution. Well, because I know this is strong, what does that tell me about it?
It's an acid.
It's an acid, good. What else?
So it's less than
Say it again, Bryce.
It completely ionizes.
So all of this
What the heck?
breaks up.
H plus
Right.
ClO. Oh.
Wait, that was filled in for me.
Yeah.
Okay?
Yo, wait,
Yeah.
the blank for the completely on the packet, it's read as since strong acids ionize completely, the blank, the concentration of.
Oh, the blank got put in the wrong spot.
Well, yeah, and then if I fill it out with concentration, it reads the concentration of H2O.
completely in
Oh, that's not confusing at all.
Yeah, and then if I put completely, ionize completely, then completely the concentration. So I don't even know what goes there.
It's completely the.
Oh wait, did I put a blank but I didn't?
Yeah, I don't think it.
I didn't leave something to
Yeah, there's something to put in.
just scribble off your blank.
It's a space.
Yeah, space.
Yeah, the blank is a space.
Wait, but then it says the.
Yeah, that's a good point. Scribble out
Oh,
the.
I did two
No,
does too.
remember,
Wow.
our brain cancels the
Don't make
second
note
the.
packets for me that night.
Yeah.
It's just proof that I don't.
That is very confusing. Okay, so coming back to this, repeating what Bryce said, we know all of this turns into these two things. When something is a strong acid, to find how much of this you have, it's really just how much of this you started with. Because all of this is turned into all of that.
Is that only if it's like 1-to-1 though?
Yes, but for acids it actually always will be, because it's just, but it is a good point in terms of how it breaks down. Yes, you would wanna look at that. So, to find the pH, I'm just gonna take the negative log of
Okay.
0.04. Because the amount of this, okay, I'm gonna write up a rice chart just to kind of show you how it's working. But you don't even need a rice chart when it's strong,
Okay.
because all of this goes away and is turned into all of this. so that's where that number, process-wise, is coming from.
Wait, what do we label this? Molar or molar?
No, pH has no units, just a number.
So, could we write pH equals?
Yeah, you do pH equals, which, what did we get?
1.40.
1.4? Yes, yeah, definitely could say pH equals 1.4. So when something is strong, you just take the concentration and take the negative log of it to find what it is, okay? Same thing's gonna happen on the base side, so here's our strong bases to add to your memorizing list for the quiz, okay? Now the bases are a little bit easier to memorize in my opinion, because there is a pattern to them on the periodic table. So it's always a metal with OH, so something OH, and it starts here. So the first group, these are all strong bases.
5.
So lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide. Technically these ones don't exist, but if they did, they'd be strong. And then starting with calcium and down are the rest of them. Calcium. Okay, so these ones and down, and then calcium and down. Yeah, and then,
Wait,
Not hydrogen?
okay, wait, never mind.
because hydrogen's not a metal.
Is there like any way to help memorize acids or no?
There's so the three that are just elements are in the same family, starting with chlorine. So HCl, HBr, HI are all strong.
No, 3 of them.
But then the other ones are all polyatomics. So, not that I've come up with. If any of you come up with a good song, let me know in future years.
5 bonus points in the test.
Oh my
area.
goodness.
If we come up with an epic song, yo Winston, Max, after school we drop that beat and just rap. You just rap out all the acids.
Can we have
the
like a
strong
minute to study right before the?
Yeah. We just play it on loop in this class so we all memorize
During the
it.
test.
Subconsciously.
Yeah.
During the quizzes.
Okay,
HCl,
now, weak acids, obviously opposite, do not ionize completely. So a weak acid always forms an equilibrium. The other interesting thing with weak acid equilibriums is they are always a reactant favored.
Let me write this chart somewhere.
What does it mean to be reactant favored?
Nick, it's a tiny number.
Say that again.
Less than 0. Or
Good,
one.
so then it's always gonna be less than 0, right, the K value will be. For another smiley face, let's write the equation first, then I'll have you write the K value. So this right here, HA is like the generic way to pick an acid without picking one. Because A is not an actual element, right?
I don't think so.
So the equilibrium equation is it breaks up into H plus and A minus. So for a smiley face from this equation, write me the Ka value.
You
Ready,
can't
go.
see that in the,
Can you not see this on that?
no, the H plus.
Oh,
Can't
it's
see
on the
that.
sunshine.
Yeah.
Walking on sunshine.
I feel like I can make a spoof out of that for you. I'm riding on the sunshine.
Ooh.
And I always ride on that dumpster.
I think you're pretty good. All right. After school, Max,
After the
we're
song.
rapping, and then we're writing an epic squeak.
I'm sorry.
I feel like we're gonna have like a whole album by the end.
Yeah.
What was that?
What are we solving?
So write me, so
Featuring
that's the
Bandage
equation.
Man.
Oh, okay.
Write me the Ka, the equilibrium expression for this.
Okay. Is this tricky?
No, not meant to be tricky, meant to be an easy smiley face.
Oh, okay.
Oh.
It's like
I mean,
this.
yeah.
So write me the equilibrium constant for this equation.
It's gotta be this, but it's probably not.
Okay.
I almost just did the biggest whoopsies of my life.
I have a question.
Yeah.
So on the example,
Products over reactants.
the example of like, sodium Oh,
Yeah,
it's
it's
so strong.
dark.
I think we skipped an example, but I'm wondering if
Oh.
it's the same as the other one.
Oh, yeah.
I didn't do the base one. It is pretty much the same, because since it's strong, all of it breaks apart. The only thing is you just have to flip it at the end, because the concentration would tell you how much OH there is.
Oh, so do you just make it like negative if it was positive?
No, you do the 14 minus your answer.
Oh.
To get it to the pH. Sorry, I must have clicked too fast on that.
Yeah, oh, he's speed click right
No,
now.
not even.
Technoblade is jealous right now. Thank you, I appreciate that.
Okay, if you have this on your paper, have a smiley face.
I was so close.
I told you it was over 8K.
Well, I cut it out because that's what we did last time.
So why didn't you?
So,
It's Avery, it's not
Ow, that hurt.
I'm so sorry.
You've been hurting me all day.
Just a fun fact. The KA setup is also on your formula sheet.
Someday I'll bring you a treat.
But, like hopefully you all recognize, all the Ks, regardless of the little subscript, are the same setup. Right? It's always products over reactants, excluding pure solids and pure liquids. Okay? But in case you have those moments where you doubt the simplest of things,
Like 3 plus 3.
right? It is there for you. So, oh, shoot. Oh,
Yeah, I feel bad.
Oh, yeah.
It's
we don't
because
have, like,
we
have
sat
3
here
minutes.
in the first, like,
Life is so short, guys.
and one problem to do. Okay, let's talk about this and then we'll do the problem, which might change your negative slightly. Okay, anyway,
We were
so,
gonna do that bonus quiz.
oh, that's next time.
I know.
Oh,
wait, what?
Alright,
take
my
away your
mind
vote.
was, my mind is just, too thin right now. I'm
So,
getting
now
close.
this is where things get a little interesting wording wise. We have a classification of strong versus weak. But within the weak category, you can classify something as a strong weak acid. What would that mean? Like,
Oh.
Moderate
It's-
acid.
One of the
It's just
strongest weak ones.
Yeah, so it's still, what does it mean by classifying it as weak?
It has equilibrium.
Yes, equilibrium, not completely broken down. What would it mean if it's a strong weak acid?
It's very reactive.
Yeah, so it's more broken down, but it's not 100% broken down.
Oh.
Okay, so in this list right here,
Oh,
the
great.
bigger the Ka value, so notice that this Ka value it gets smaller as we go down. This acid, hydrofluoric, would be classified as a strong weak acid.
Wait, do we have to memorize this for the...
No, so that's the benefit of memorizing the strong ones, is by default, any other acid you see has to be weak.
Oh, yeah.
Okay, I'm gonna hand this to you, and then I'll tell you which of the problems you can do and which ones you need to wait to do. You need to do problems 1 and 2.
Okay.
Let's go.
It's really hard.
Did we rough
Thank you.
Really gotta...
Gotta map that out.
Dang, I'm not gonna.
What time is our, or what day is our lab? Like our late chapters lab due?
It's open through Wednesday of next week.
Okay.
So that is a good reminder for everybody, Evan, that yeah, your lead shot leading lab is due next Wednesday, if you are still working on it.
Gotta say, Michelle here would be a sick name.
Okay, any questions about these?
Which one's doing that right now?
So you only know how to do problems 1 and 2 right now. Because all the rest are how to solve weak ones, which are a little different than solving the strong ones.
Wow.
Good?
Amazing.
Fantastic.
Any questions?
I don't understand.
Probably not.